Right, let me go through these guys real quick here for you, and hopefully this will help with some homework. So number 2, they're giving us the radius as a big giant number. They want us to write it in standard form, which just means scientific notation. So that means our decimal needs to be here so that it can be a number between 1 and 10. So we're going to take this decimal that would technically be here, and we're going to bump it over 3, 6, 7, 8, 9 places. So that number is going to become 4.72 times 10 to the 9th, since we moved it 9 places. So that's the radius. So if I plug it into our formula for circumference and volume, it will look something like this. So if that's the radius, the circumference is going to be, let's see, it's 2 pi r. So 2 pi, and then my radius, which is 4.72 times 10 to the 9th. And you don't need a fancy calculator for this. Any calculator should be able to handle those values. So if you just hit this times this times this times this to the 9th power, you should get the right answer. So any basic calculator should be able to handle that. For the volume, I believe, look in our formula packet, I think it is 4 pi r cubed. You might need to check our formula packet to see if I am saying that formula correctly. But if the planet is a sphere, right? It's a ball or a sphere. So if you look in our formula packet, you will see the volume of a sphere. So if this isn't correct, you can see in the formula packet. I'm trying to go off memory here, so I can make a short video for you. So, but again, I'm simply going to take that radius again and plug it into this formula, and this is the 3rd power. And again, any calculator should be able to do this. And you could type it in parts if you want. You could do this times 10 to the 9th and then hit enter. You could take that answer and raise it to the 3rd power. You could then take that answer and multiply it times pi and then times 4. So you can do it in pieces if you don't want to do it all at once. So let me go back to the book really quick. So a 2,000 meter to the nearest meter, length of cable. So what's confusing about this one is if you think of what a cable would look like a rope, technically that is a cylinder. At least the shape that it would take would be a cylinder. So that's really what this is. They're giving us the radius and they want us to find the volume. So again, we are finding the volume of a cylinder. The height of it would be 2,000, and this is the radius. So if you go to your formula packet, look at the volume of a cylinder, simply put this in for the height, and put this in for the radius into that formula, and then just simplify it. And again, any calculator should be able to handle numbers like this. So just try plugging that into your volume of a cylinder. Again, that's your height, that's your radius, and that's all you need to know for the volume of a cylinder. So go look at the formula packet for that one so you can take a look and see what that is. Let's see, world's ocean, 23 million, So cubic, again, that means volume if something is cubic. If it were a giant ice cube, what would be the approximate length of each side? So what they're saying is they are giving you the volume of a cube, and we need to figure out what each side length would be. So 23 million. So here's what that's going to look like. So if I have 23 million, which would be this, right? That's 23 million. So this represents the volume. So volume of a cube, remember volume of a cube or a prism, which is in your formula packet, is just length times width times height. Well, in a cube, these are all the same. So that makes your volume the side length times itself, right? So that's the easier way to look at it when you're doing volume of a cube. So if this is my volume, that tells me that 23 million is my volume. So then how would we solve that equation to figure out one side length? So we would then cube root both sides in order to get one side length. And again, your calculator should be able to do the cube root of 23 million. And then let me jump back real quick. So again, they're giving me a formula right here. We just need to plug in the information. So let's see, C is this. So you're going to take that number, plug it right on in there for C. Let's see, the unit of measurement of energy released. So this is the one we don't know, is M. So this is going in for C. Where'd it go? This number. Sorry, there it is. So this is the number going in for E. So this is the energy, that's the number going in for E. You are solving for M. So after you plug in the value for C and for E, just solve that equation for M, get M by itself. The last one, so Lindy has an approximate heart rate of 83 beats per minute. All you have to do on this one is convert minutes to years. So there's several conversions that you would have to go through to do that. So if 83 beats per minute, well, there's 60 minutes in an hour. So I have to multiply this by 60. There are 24 hours in a day. So you got to multiply that answer by 24. There are 365 days in a year. So multiply by 365. And you're doing it for 78 years. So multiply by 78. And then that should give you your total. Okay, so hopefully that helped. Let me know if it didn't, and I'll help you further.